This is our third video on vectors, and we are going to talk about the dot product and the angle between two vectors. The dot product looks like this. Let's say we have two vectors, u and v, if we wanted to find the dot product, we multiply the components. So we're going to multiply u1 times v1, then u2 times v2, and we will add those products together. So it's u1 v1 plus u2 v2. So here's an example. Let's say we had 4, 5, and negative 2, 3. The dot product would be 4 times negative 2 plus 5 times 3. That's negative 8 plus 15, which is 7. Now notice that the dot product is a scalar. Now there's something kind of cool about the dot product that I want to show you. Let's say that we've got a vector 2, 3, and we're going to find the dot product of u with itself. That would be 2, 3, 2, 3, and we get 13. All right, now watch this. If we find the magnitude of u, we get radical 13. So notice here we've got this relationship between the dot product being 13 and the magnitude being radical 13. And that relationship is, if we square the magnitude, we get the dot product of u with itself. Now the dot product is actually useful in helping us find the angle between two vectors. So let's start just with a picture. Let's say we've got two vectors here, u and v. Here's the angle in between u and v. Now there's a third vector, this vector here, which would be the difference between the two. Now you remember from our last chapter that if we have three sides of a triangle, we can find an angle using the law of cosines. So the law of cosines looks like this. We've got that. So let's do a little substituting. B squared and c squared, we're going to use u and v. And the length of these vectors would be their magnitudes. So we're going to have the magnitude of u squared plus the magnitude of v squared minus 2. Am I going to fit this? Cos of theta. And that's going to be equal to a squared, which is this v minus u squared. Now we're going to focus just on this part for a moment. We know that the magnitude of a vector squared is really the dot product of that vector with itself. If we distribute, we're going to get v squared, right, v times v, minus 2u times v, plus u dot u. Now we also know, right, here again we have the dot product of vectors with themselves, so we can write that as magnitude squared. Now remember that this whole thing up here is equal to this whole thing down here. So I'm going to write that out again. Let's go with our magnitude of u squared from the top. Magnitude of v squared is equal to our last line here. And you might notice from this long, ugly expression that we've got a magnitude of u squared on both sides and a magnitude of v squared on both sides. So why don't we cancel those out? Here's our magnitude of u, magnitude of u, magnitude of v squared, magnitude of v squared. And we're left with this right here. Okay, I'm going to bring this on to another page. Okay, one more step. What I'm going to do with this is solve for cos theta. We're going to isolate cos theta by dividing both sides by this expression. And we end up with all of this canceling here. This is also gone. So now all we have is that cos theta equals u dot v over the magnitude of u times the magnitude of v. Now you're generally not responsible for proofs or derivations in this course, but the reason that you saw this right now is because you should understand that this formula here, this formula, comes from the law of cosines. So let's see how this works. We've got two vectors, 4, 3, and 3, 5. And we'd like to find the angle between the two. Well, here's our formula. Okay, so what we need are three different things. First, we need u dot v. So that's 4 times 3 plus 3 times 5. Which is 27. We need the magnitude of u. So the magnitude of u is 5. And then we need the magnitude of v, which is radical 34. Okay, so we're going to take those three values and substitute into our equation. We've got cos theta equals 27 over 5 radical 34. We solve for theta, and this isn't from one of our special triangles, so we will need the calculator for this. I'm going to round to the nearest tenth, and we get 22.2 degrees between those two vectors. Okay, two more things about this formula. One of them being that we can take this and cross multiply here and get u dot v is equal to this, which is an alternative formula for your dot product. And the second thing is that we can use this dot product here in the numerator to help us determine if two vectors are orthogonal, which means perpendicular. Let's say we've got these two vectors, and we would like to know if they are orthogonal. Now, one way we can go about this is we can find the dot product, find the magnitude, plug in, and then solve for cosine. Or we can think about the fact that if two angles, or if two vectors are orthogonal, the angle between them is 90 degrees. And we know that the cos of 90 degrees is equal to 0. So in order for this fraction here to be equal to 0, the numerator would have to be equal to 0. So we're really just looking to see if u dot v is equal to 0. So let's say u dot v is equal to, we get 12 minus 12, which is 0. So now let's write a little conclusion here. We know that u and v are orthogonal because u dot v is equal to 0. And here's our summary. We know in order to find the dot product of two vectors, we multiply their components and add those products together. And we're going to remember that the dot product is a scalar. An alternative formula would be the magnitude of u times the magnitude of v times cos theta. And we also want to keep in mind that the magnitude squared is equal to the dot product of a vector times itself. To find the angle between two vectors, we derived this formula. We know that it comes from the law of cosines. And we also know that two vectors are orthogonal if their dot product is equal to 0.